Probability random experiments, set of all outcomes is sample space. Any subset of a sample space is called an event. It is denoted by capital A, B, etc. also can be used. Okay, our first few questions are to write the sample space, because if you can write the sample space properly, only you will write the total number of outcomes and the number of favorable outcomes, everything from that sample space. So please see, a coin is tossed thrice. Write its sample space. Yes, those who were absent, hope you all have noted the introductory part. Random experiment and sample space, then event. A coin is tossed thrice. Write its sample space. Coin is tossed thrice means total 2 raised to 3. That is 8 outcomes are there. Total 8 outcomes. 2 raised to n is a formula for finding outcomes when coins are tossed. 2 raised to n. So here 2 raised to 3, which is 8 outcomes. So these 8 outcomes we list out like this, starting with H, 4 outcomes, starting with tail, 4 outcomes, like this: HHH, HHT, HTH, HTT. Like this, begin with H, 4 outcomes, and begin with T also, 4 outcomes: TTT, TTH, THT, THH. Like this, total 8 outcomes. If a coin is tossed twice, then what will be the number of outcomes? Coin is tossed twice. Please unmute and say, coin is tossed twice. What will be the number of outcomes?
2 raised to 2.
2 raised to 2. That is 4 outcomes. HH, HT, TH, and TT. If coin is tossed twice. For dice, the number of outcomes is 6 raised to n. 6 raised to n. If it is one die, 6 raised to 1. That is 6. 1, 2, 3, 4, 5, 6. In class 10, you have studied. If there are 2 dice, the number of outcomes will be 6 raised to 2. 6 raised to 2 is 36. That also you have studied in class 10. 1, 1, 1, 2, 1, 3, etc. 1, 6. 2, 1, 2, 2, 2, 3, etc. 2, 6, etc. till 6, 1, 6, 2, 6, 3, etc. 6, 6. Like this, total 36 outcomes for dice. So second model question I have done for writing sample space last class. A coin is tossed. This type of connected events also can be asked in class 11. Coin is tossed. Coin is tossed means H and T, head and tail. And then a die is thrown. So coin is tossed means head and tail. Then a die is thrown means with head, H1, H2, H3, H4, H5, H6. Because with head, next to that one a die is thrown, means 1, 2, 3, 4, 5, 6 will be connected to that event. H1, H2, H3, H4, H5, H6. Next, with the tail also the same way, T1, T2, T3, T4, T5, T6. Is it clear, children? Connected events, how to write? Coin is tossed and then a die is thrown. Write the sample space. All possible outcomes we list out like this as a set, and we get the sample space. Clear? Okay, one more example. So these examples, direct questions may come to write the sample space, but the main question will be to write the total number of outcomes and to find the probability. In that type of question, this is useful. Next, an experiment consists of tossing a coin. So this is also a connected event. Tossing a coin and then throwing it second time if a head occurs. Last class we have done this as well. Those who were absent, please note down this also to your notebook. Experiment consists of tossing a coin and then throwing it second time if a head occurs. If a tail occurs on the first toss, if a tail occurs on the first toss, if a tail occurs on the first toss, then a die is rolled once. Then a die is rolled once. Write its sample space. Write the sample space. Write the sample space. Yes. So here, how to write? Coin is tossed. Again, coin is tossed means head or tail. You can see, first of all, I have drawn this and explained like this, head or tail. If head occurs, then throw it second time. Throw the coin second time. That means connected to head, it will be H or T, head or tail, because throw the coin second time with head. So you can say that in the sentence, tossing a coin and then throwing it second time if a head occurs. If a tail occurs on the first toss, then a die is rolled once. So with tail, a die is rolled once. Means 1, 2, 3, 4, 5, 6 with the tail. 1, 2, 3, 4, 5, 6 with the tail. So this is the sample space. HH, HT, then T1, T2, T3, T4, T5, T6. This is the sample space. Is it clear? So please note down the answer. Head or tail. With head, the coin is tossed again. With head, HH, HT, and with tail, die is rolled once. Yes. So the clear knowledge of sample space, that will help you to write the total number of outcomes. All of you know the formula for finding probability. Probability is number of favorable outcomes by total number of outcomes, right? Probability of an event is number of favorable outcomes by total number of outcomes. Favorable outcomes will be the number of elements from the event. Yes. Now please write the next details about events. So we study in detail about the events to write the number of favorable outcomes. So please write that one. What even be event? Already you have written in the notebook. What is an event? Any subset, right? Any subset of a sample space is called an event. Any subset of a sample space is called an event. So please write, and the categories, different types of events and all. Once again, we are writing that definition of event. Right, event. Any subset of a sample space is called an event. Any subset of a sample space is called an event. Any subset of a sample space is called an event. Example, let S be the sample space of throwing a die. Let S be the sample space of throwing a die. Let S be the sample space of throwing a die. Now S is equal to set of all 1, 2, 3, 4, 5, 6. S is set of all 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let A be the event of getting. Let capital A be the event of getting. Let capital A be the event of getting an even number, and capital B be the event of getting a prime number. Be the event of getting a prime number. Then A is equal to set of all 2, 4, 6. And B is equal to set of all 2, 3, 5. B is a set of all 2, 3, 5. Even number and prime number. Now, probability of A. What is P of A? P of A means probability of A. Probability of A means number of elements in A upon number of elements in the sample space. So in A, how many elements are there in A? 3, right? Upon 6, that is 1 by 2. Same way, probability of B is also number of elements in B upon number of elements in S. So that is 3 by 6 equal to 1 by 2. So this way, we have to study detailed about events also to write the probability. Probability is number of elements in the event upon number of elements in the sample space, or number of favorable outcomes by total number of outcomes. Please write. Next, subheading, types of events. Subheading, types of events. Please write. Types of events. Types of events. First one, impossible and sure events. Impossible and sure events. Impossible and sure events. Last year also you have studied these two words. Impossible event means if probability of an event is probability of null set, that means if there is no element in an event, it is called impossible event or it is null set. And what will be probability of impossible event or probability of null set, you know? There is no element. So 0 by number of elements in the sample space, so it will be 0. So please write. The empty set. The empty set. So we put this null sets symbol, empty set. Is called an impossible event. Is called an impossible event. Impossible event. And the sample space S. And the sample space S is called a sure event. So we call the empty set as the impossible event and the sample space S is the sure event. Now, probability of empty set, P of empty set, probability of empty set is how much? it is 0. And probability of sample space S is equal to 1. Because number of elements in S by number of elements in S, P of S sure event will be 1. And all of you know, probability is a real number which lies between 0 and 1, including both. Last year we have studied that one as well. 0 less than or equal to P of A less than or equal to 1. Next, second in types of events, second one is symbol event. All right, second one, symbol event. Symbol event. Symbol event means if there is only one element, in an event or in that subset, if there is only one element, we call it a symbol event. Please write. If an event E has only one element, it is called a symbol event. If an event capital E has only one element, it is called a symbol event. It is called a symbol event. If an event E has only one element, it is called a symbol event. Next, if there are more than one elements, we call it as compound event. If an event has more than one element, it is called a compound event. That is number 3, compound event. Compound event. Compound event. Right. If an event has more than one element, it is called a compound event. If an event has more than one element, it is called a compound event. If an event has more than one element, it is called a compound event. So these are the types of events. If there is no element, it is impossible event or null set. One element is symbol event. More than one element is compound event. If the number of elements is equal to number of elements in the sample space, it is sure event. Next, exactly similar to set, we do the calculations based on event. In set, you studied a union, intersection, complement, and difference. These notations you studied in set. Union, intersection, complement, and difference. So these notations we use here also as basic notations. For example, A or B, if or is a connecting word, in permutations and combination also you have used this one. We put A union B, or A or B is A union B. A and B, that will be A intersection B. A and B is A intersection B. Not A, in questions the word will come like this, not A. Not A means A complement. Not A is A complement. So please write. Algebra of events. Subheading, algebra of events. In bracket, basic notations. Basic notations. So these notations, we take it from set only, the first chapter set. Same notations that we have used in set, we will connect it to the events. Okay, the first important one is not A. In set, you will frequently see this one, not A. Okay, for not A, we put this symbol A complement, A complement. Not A is same as A complement. Not A, we put this sign A complement. Not A is A complement. Another important notation is A or B. A or B. A or B is A union B. So if or is a connecting word, it is union. A or B means it is A union B. A or B is same as A union B. Next is A and B. A and B means A intersection B. See, if and is a connecting word, it is intersection. A and B is A intersection B. Next is A but not B. A but not B. A but not B is A minus B. But that A minus B we calculate like this. A intersection B complement. Means A is there, but B is not there. A intersection B complement. A intersection B complement. So in sums, we will write it again like this. A minus, that means elements which are there in A and not in A intersection B. So this way you will calculate A but not B. That means probability of A minus probability of A intersection B will be enough to find P of A but not B or A minus B. Because this is the set of A minus B. A minus B means elements which are there in A and not in B. Elements which are there in A and not in B. So we get this part, the part of A. That means the circle of B is fully exempted here, A minus B. So it is same as from A, we subtract A intersection B. So that is what it is written like this, A minus of A intersection B, A but not B. Next important one is neither A nor B. In set also you have seen this one, neither A nor B. Neither A nor B. Yes, that you may remember. What is neither A nor B? Do you remember? Neither A nor B. In set you have studied this one, neither A nor B. Neither A is not there, A complement. And B is not there, intersection B complement. Okay, so that we calculate like this, A intersection B complement. By De Morgan's law, it is same as A union B the whole complement. In the chapter set, you have studied this one. Neither A nor B means it is A union B the whole complement. Next, at least one of A, B or C. At least one of A, B or C. This also is studied in Venn diagram questions from set. At least one of A, B or C means it is A union B union C. At least one of A, B or C is same as A union B union C. at least one of A, B, or C is same as A union B union C. Please write. Next, for events, there are two important terms: mutually exclusive events and mutually exhaustive events. In class 12, again in probability, you have sums based on these two events. So please write the subheading mutually exclusive events. Mutually exclusive events. Mutually exclusive events. Mutually exclusive events. Mutually exclusive events means if there is no common element between two events. So it will be like this. So this is a sample space, rectangular shape. That universal set represents sample space in probability. This is our first set, capital A, and this is our second set, capital B. So there is no sharing region between these two. That means A intersection B is, what is A intersection B for these type of events? That is fully detached. There is no common element between. That means A intersection B is null set. These type of events are called mutually exclusive events. It is not only two or more events. This definition is valid for two or more events. Their intersection will be null set. So please write two or more events. Two or more events associated with a random experiment, associated with a random experiment are said to be mutually exclusive. Are said to be mutually exclusive if their intersection is equal to null set. If their intersection is equal to null set. Is equal to null set. If their intersection is equal to null set. In general, if two events A and B are mutually exclusive, then A intersection B is equal to null set. In general, if two events A and B are mutually exclusive, then A intersection B is equal to null set. A intersection B is equal to null set. So that diagram in the reference phase shows mutually exclusive events. So simply mutually exclusive means there is no common element between two events. Then the events are mutually exclusive events. Yes, is it clear, children? Sunny Thomas, Ismail, Simran, Stefan, all of you understood? Mutually exclusive events. Haider, Sanobar, Alfin. Okay, next is mutually exhaustive events. A similar word is there, but this is different. Mutually exhaustive events. So please write. Mutually exhaustive events. Mutually exhaustive events. So here there will be n events, and this is the sample space, and there are n events associated with this sample space like this. First event I take E1, second is E2, third E3, then E4, etc. Last is En. So these are mutually exhaustive, means there may be common element, may not be common element, that doesn't matter, but the union of these events, that will be equal to the sample space. That means the sample space is partitioned into n events, or the union of these events will be equal to the sample space. When we combine all these events, we get the entire sample space. So this is the definition. Two or more events, right? Two or more events. Two or more events associated with a random experiment. Associated with a random experiment. Associated with a random experiment are mutually exhaustive. Are mutually exhaustive if their union is the sample space. If their union is a sample space. Two or more events associated with a random experiment are mutually exhaustive if their union is a sample space. In general, if the events E1, E2, etc. En, E1, E2, E3, etc. En are mutually exhaustive. Are mutually exhaustive. Are mutually exhaustive if E1 union, E2 union, etc. union En is equal to, yes, the sample space. E1 union, E2 union, etc. union En is equal to the sample space S. E1 union, E2 union, etc. union En is equal to the sample space S. Please write. Okay, so now the major part of this chapter is finding probability only. But before starting probability, already we have studied probability basic results in small classes. And this year we have an additional result, that is the formula for P of A union B. So after writing these results, we are going to start the probability based questions. Yes, this is clear still the theory part. Any doubt? The types of events, algebra of events, the set notations, then the two additional definitions, mutually exclusive events and mutually exhaustive events. Okay, so hope you all completed till here. Now write the subheading, probability of an event. Probability of an event. Probability of an event. Right. Probability of an event is denoted by like P of E or P of A. P of A is equal to number of favorable outcomes by total number of outcomes. In class 9 and 10, you have studied the same. So there is no change in that definition. Number of favorable outcomes. Number of favorable outcomes by total number of outcomes. By total number of outcomes. Or this is same as number of elements in A by number of elements in S. This is the definition of, or the formula for finding probability. So this is N of A by N of S. So probability is number of favorable outcomes by total number of outcomes. Next point. Probability is always a number which lies between 0 and 1, including both. 0 less than or equal to P of A less than or equal to 1. Please write 0 less than or equal to P of A less than or equal to 1. Only we studied when probability is 0, it is impossible event. Probability is 1, sure event. In case when you solve a problem, if you get probability as more than 1, it is wrong. Probability cannot be more than 1. Probability cannot be negative. Okay, this type of answers, if you get, that will be wrong answers. Probability is a number which lies between 0 and 1, including both. Next point, that one last year also you have studied. Probability of an event A plus probability of A complement. A complement means not A is equal to 1. The total probability of an event A and its complementary event is 1. And from there we write probability of A complement. Yes, what is probability of A complement? It's 1 minus P of A. Probability of A complement is equal to 1 minus P of A. Probability of A complement is 1 minus P of A. Then point number 3 is a very important formula from class 11 textbook, addition theorem of probability. 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 See, this is the addition theorem. P of A union B or P of A or B. P of A union B is equal to P of A plus P of B minus P of A intersection B. So this formula is called the addition theorem of probability. P of A union B is equal to, everyone should by heart this formula. We have important sums based on this one. Our long answer type of this year is based on this formula. P of A union B is equal to P of A plus P of B minus P of A intersection B. Then if A and B are mutually exclusive events, if A and B are mutually exclusive events, then what will happen to this formula? If A and B are mutually exclusive events. A intersection B is equal to null set, right? A and B are mutually exclusive means A intersection B is null set. Then what is P of A intersection B? Probability of null set. Probability of null set is 0. So when you substitute that one to the above formula, we get P of A union B is equal to P of A plus P of B. P of A union B is P of A plus P of B. So when A and B are mutually exclusive events, A intersection B is null set, or P of A union B is P of A plus P of B. In the chapter set, you have studied a similar formula for number of elements of A union B. What was that formula? N of A union B is, in the chapter set you have studied, N of A union B is equal to, please unmute and respond, children. N of A union B, in the chapter set you have studied, N of A union B, N of A plus N of B minus N of A intersection B. Actually, this is a derived formula from that one. And to that formula, if you divide by N of S, N of A by N of S will become probability of A. Okay, probability of A. So it is a derived formula from N of A union B. So this is very important. P of A union B in probability, P of A plus P of B minus P of A intersection B. So based on these, we have the majority of sums. So we are going to start these sums based on this formula. In the examination also, our questions will be based on this formula. So after taking attendance, I will start the questions. By that time, please revise. If there is any doubt, you can ask. Attendance Aaron. Aaron Ebi. Alfin.
Present, sir.
Alvinia. Antrin. Antrin. Aryan.
Present, sir.
Ashlyn.
Present, sir.
Odad.
Present, sir.
Osti Francis.
Present, sir.
Okay, my 3 it is noted, no problem. Next, Belicia. Belicia.
Present, sir.
Yes, yes. Elena.
Present, sir.
Haider.
Present, sir.
Ismail.
Present, sir.
Janisha.
Present, sir.
John Biju.
Present, sir.
Joshua Fernandez.
Present, sir.
Joshua Abel.
Present, sir.
Jovita.
Present, sir.
Joyson.
Present, sir.
Keithani. Keithani. Kevin.
Present, sir.
Kevin John and Kevin Sargent both are present. Livia. Mahek.
Present, sir.
Maitri.
Present, sir.
Muhammad Musamil. Noel Joshua.
Present, sir.
Ruth.
Present, sir.
Sanobar. Sheikh Fatima.
Present, sir.
Shashant.
Present, sir.
Shivali.
Present, sir.
Simran.
Present, sir.
Smith Kubal.
Present, sir.
Yes. Stefan.
Present, sir.
San Thomas.
Present, sir.
Victor.
Present, sir.
Vigash.
Present, sir.
Vishnu.
Present,
And
sir.
Yunus.
Present, sir.
Okay. So now let's start sums based on probability. So please write. A coin is tossed twice, right? A coin is tossed twice. A coin is tossed twice. What is the probability that at least one tail occurs? What is the probability what is the probability that at least one tail occurs? At least one tail occurs. A coin is tossed twice. What is the probability that at least one tail occurs? Okay, children. So coin is tossed twice in all these type of questions. If possible, if you can list out the sample space, you have to do that one. For coin, the number of outcomes is 2 raised to n. For twice, 2 raised to 2, 4 outcomes. 4 outcomes. Okay, 2 raised to n is the formula for finding number of outcomes, number of elements in sample space of coin. So these are the outcomes HH, HT, TH and TT. TH and TT. Okay. So let A be the event of getting at least one tail. So let capital A be the event of getting at least one tail. At least one tail. At least one tail. What does it mean? Last year also you have studied. At least one tail means one tail or more than one tail. At least one tail means one or more. One or more. One tail or more than one tail. If the word is at most one and less than one. At most is one and less than one. At least is one and more than one. So at least one tail means one tail and more than one tail. Yes. So what will be that one and how to calculate at least one tail? So we will list out the outcomes. One tail cases are HT and TH, one tail. More than one tail, it is TT. Okay, or two tails, it is TT. More than one tail is TT. Yes. Now let's list out the outcomes like this and we can easily write the probability. Now P of A Sorry, this is not P of A, instead A. We just listed out A here, and then we have to write P of A. Next line. P of A is a number of elements in A, that is 3, by number of elements in the sample space. So it is 3 by 4. Clear? Last year also you have studied these type of words at least. Cards based questions can be asked. Last year also you have studied this in detail. So please write a short note about that one. Total, how many cards are there in the deck of cards, you know?
So
Total
52.
52 cards. 52 cards are there in the deck of cards. 52 cards. We split that one into red and black. Red, how many red cards are there? It's half,
26.
26. And black, how many are there? Black also 26. Red 26, black 26. Again, this red group, we break this into two. Red. Yes, what are the two categories of red cards? All of you know this.
Diamonds.
Hearts and diamonds, 13 each. Hearts and diamonds, 13 each. Hearts 13, diamonds also 13. And what are the black cards?
Spades and clubs.
Yes, spades and clubs. Spades 13, clubs 13. Probability of getting a spade is 13 by 52. Probability of getting a club is also 13 by 52. Probability of getting a red card is 26 by 52. Like this, different questions you can easily write by learning this. Again, each 13 card is categorized like this. Each 13 card. So this is the category of 13 cards. There is a king. There is a queen. There is jack. And then ace. Then the number cards 2 to 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is these are the 13 cards in each slot. 13 cards. So total how many kings are there and what is the probability of getting a king? What is the probability of getting king?
4 by 52.
4 by 52. In each slot, one king each, like this. Total 4 kings. So these are some example questions based on these cards. Last year also you have studied in detail. Probability of getting a king, P of a king, is 4 by 52. 4 kings are there in total. So that is 2 by 26 or 1 by 13. 1 by 13. Probability of getting a black king. Yes. How many black kings are there? Which means black colored spade and
2 by
club.
52.
Yes. In spade there is one king and clubs one king. So it is 2 by 52 equal to 1 by 26. Black kings 2 by 52, that is 1 by 26. King, queen and jack are also called what is special name for these three?
Face cards.
Face cards.
Face
Very
cards.
good. Face cards. Last year you have studied. Face cards. King, queen and jack are also called the face cards. 3 face cards in each category. So total number of face cards. What is the probability of getting a face card?
12 by 52.
Correct. 3 times 4, that is 12 by 52. Yes, when you cut this with a 4, what do you get? 3 by 13. 3 by 13. Probability of getting face card is 3 by 13. Probability of getting a red face card. Probability of getting a red face card. What is probability of red face card?
6 by 52.
Correct. 6 by 52. Red face cards. In hearts, 3 are there. Diamonds, 3 are there. So 3 plus 3, 6 by 52. Red face card. Okay. Next, probability of getting a diamond and a king. Diamond and a king. If the connecting word is and, the one which is common in these two, that means in diamond group, how many kings are there? So that should be
1 by
counted.
52.
1 by 52. Diamond and a king, that is 1 by 52. Diamond and a king is 1 by 52. But if there is a slight change in the connecting word, instead of and, if the word is or, that also you have studied last year as extra question. Diamond or a king, what will be this? Probability of getting diamond or a king, you know. So this one we have to add them and subtract the common one. Diamond 13 cards are there, diamond plus. Kings, 4 kings are there, but 1 king is already counted in the diamond 13 cards. So remaining 3 more kings, 4 minus 1, 3. So it will be, total will be 13 plus 3 by 52. Is it clear, children? If the connecting word is or, we take the total. Diamond 13 cards, king, 4 kings are there, but 1 king is already counted with the diamond. So 4 minus 1. That 1 we don't have to count again. So that is what I have added 3. So 13 plus 3. What is that? 16 by 52. 16 by 52. So this one you can break. 16 by 52. Yes, is it clear? 16 by 52. When you simplify, what do you get? Divisible by 4. 4 by 13. 4 by 13. 4 by 13. I repeat, diamond or a king means we have to add, take the total. If or is a connecting word, we should take the total, but avoid the common one. The repetition should be avoided. Diamond 13 cards are there. Kings 4 are there, but 1 king is already counted with the diamond. So 4 minus 1. So we have added 13 plus the remaining 3 kings. Is it clear, Kevin? Diamond or a king?
Yes, sir. Okay.
Diamond and a king. Diamond and a king means the common one. In diamond group, how many kings are there? Only 1 king. So that is what is called a diamond and a king. So it is 1 by 52. And connected to or, another similar one can be asked. Probability of neither diamond nor king. Probability of neither a diamond nor a king, It is exactly the remaining cards. Neither a diamond, which means it is not a diamond, it is not a king. So this type of cards we count like this. 16 cards are there, diamond or king. The remaining cards will be 52 minus 16 by 52. So when you get a question by connecting neither a diamond nor a king, we have to take diamond or a king first, that is 16. So 52 minus 16 by 52. What is 52 minus 16? 36 by 52. 36 by 52. How much you get when you cut this one? 9 by
13.
13. 9 by 13. The same thing we can calculate 1 minus 4 by 13 because total probability is 1. So it is exactly the negative of diamond or a king. 1 minus 13 by 4, 4 by 13. 1 minus 4 by 13, you will be getting the same answer, 9 by 13. Okay? Is it clear? So neither a diamond nor a king is exactly the negative of the complementary case of diamond or a king. So hope you all understood the different varieties of questions based on cards. So this is also not only for class 11, class 10 you have studied this one. So class 11 and class 12 also cards questions we have, okay. All of you understood? Should I explain any part again? So this diagrammatic explanation is also very important. That will help you to understand this topic faster about the cards. Okay, ace is not a face card. Ace is not a face card. Face means there are pictures on cards. That is king, queen, and jack. Any other doubts, children? Yes, Jovita, it is noted. Yes. Next, more sums based on this place, right? Given P of A is equal to, given P of A is equal to 3 by 5 and P of B is equal to 1 by 5. P of B is equal to 1 by 5. Find P of A or B. Find P of A or B if A and B are, mutually exclusive events. Mutually exclusive events. If A and B are mutually exclusive events, please write. Given P of A is equal to 3 by 5, P of B is equal to 1 by 5. Find P of A or B if A and B are mutually exclusive events. So we start like this. P of A or B is equal to, what do you mean by A or B? It is A union B, right? P of A union B. When these are mutually exclusive events, we know A intersection B is null set, or P of A intersection B is probability of null set, that is 0. Probability of null set, it is 0. So this becomes P of A plus P of B minus P of A intersection B, that will become 0. Then what will be the answer? We just add them, you will get the answer. Actually, the formula is P of A plus P of B minus P of A intersection B. So that P of A intersection B will become 0. So this is 3 by 5 plus 1 by 5. What is answer? 4 by 5 is the answer. Clear? Answer is 4 by 5. Yes, done. Next question. Yes, all of you finish this one. Okay, next question. Right. If E and F are even such that if E and F are even such that if E and F are even such that P of E is equal to 1 by 4, P of E is equal to 1 by 4, P of F is equal to 1 by 2, P of F is 1 by 2, and P of E and F is equal to 1 by 8. P of E and F is equal to 1 by 8. Find first one, P of E or F. P of E or F. Second, P of not E and not. Second subdivision, P of not E and not F. P of not E and not F. Please write. If E and F are even such that P of E is equal to 1 by 4, P of F is equal to 1 by 2, and P of E and F. What do you mean by E and F? E and F is?
E intersection F.
E intersection F.
E intersection F. So please write P of E is 1 by 4, P of F is 1 by 2, P of E and F means P of E intersection F. So this is equal to 1 by 8. This is 1 by 8. And first one, we should find P of E or F. P of E or F means P of E union F. We have the formula P of E union F. Yes, what is P of E union F? It is P of E plus P of F minus P of E intersection F. P of E plus P of F minus P of E intersection F. Then substitute. P of E is 1 by 4 plus 1 by 2 minus 1 by 8. 1 by 4 plus 1 by 2 minus 1 by 8. 8 is the common denominator and simplify 4 times 2. So 2 plus 4 minus 1. Yes, what is answer? 5 by 8. So the first answer is 5 by 8. Please write first answer 5 by 8. Then the second one. Yes, did you complete the first one? Any doubt? What is second one? Second one already we have discussed. Not E. Not E means E complement. Not E. And means the connecting word, connecting sign is intersection. So what will be this? Not E and not F. Not E is E complement. And is intersection, F complement. Not F is F complement. In the chapter 1, you have studied, yes, Mahik, correct answer, Oda, the correct answer. You have studied De Morgan's law. Do you remember De Morgan's law? E complement, intersection, F complement. How can we write by De Morgan's law? Yes, those who know De Morgan's law, please unmute and say how to write E complement, intersection, F complement.
E union F the whole complement.
Correct. P of E union F the whole complement. In chapter 1, you have studied this as De Morgan's law. The reason is by De Morgan's law. De Morgan's law. So De Morgan's law, by De Morgan's law, we can write E complement. intersection F complement is E union F the whole complement. Now, whole complement, we can write this as 1 minus P of E union F. So this is equal to 1 minus P of E union F. Already we found P of E union F. It is 5 by 8. So 1 minus 5 by 8. What is answer? 8 minus 5 by 8. Answer is 3 by 8. Hope you all understood both the subdivisions. Any doubt? Okay, next sum. Events E and F are such that. Next question. Events E and F are such that events E and F are such that P of not E or not F is equal to 0.25. P of not E or not F is equal to 0.25. State whether E and F are mutually exclusive. 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 So please write this one. Events E and F are such that P of not E or not F is equal to 0.25. State whether E and F are mutually exclusive. You know, for mutually exclusive events, E intersection F must be null set, or probability of E intersection F must be 0. Yes, how can we do this? It is given P of not E or not F is equal to 0.25. Not E means E complement. For or, what sign you put in between for or? Union or intersection. Union, correct. Union. F complement is equal to 0.25. All of you understood this? Not E means E complement. Or is union. Again, by De Morgan's law, we can write the union of separate complementary events as intersection of the entire complement. So how will you write this by De Morgan's law? It is P of E intersection F, the whole complement. So this is P of E intersection F, the whole complement. All of you understood? E intersection F, the whole complement. From this one, from this step, can you find out P of E intersection F? I'll give you 1 minute. All of you please try. Try to get P of E intersection F from here. If you get P of E intersection F as 0, these are mutually exclusive events. If it is not 0, it is not mutually exclusive. What is your conclusion? Send it in the chat box. Kevin and Oda, they got correct answer. Others also please respond. Kevin Sajan and Oda, correct answer. So, you know, E intersection F, the whole complement is 1 minus P of E intersection F is equal to 0.25. So now 1 minus 0.25 is P of E intersection F, or we can write P of E intersection F is equal to 0.75. Okay, so that is not equal to 0, which means E intersection F is not equal to null set. That is, E intersection F is not equal to null set. Therefore, E and F are not mutually exclusive events. E and F are not mutually exclusive events. E and F are not mutually exclusive events. Next, one more question. Please write. A and B are even such that A and B are even such that P of A is equal to 0.42. P of A is equal to 0.42. P of B is equal to 0.48. P of A and B is equal to 0.16.
So,
Yes.
so for the previous question, you had written 3 of E intersection F4 complement is 1 minus P of E union F complement.
No,
But
no, no.
for this question,
Last question, it was E complement intersection F complement. Can you see this one? So there are two De Morgan's law. One is intersection can be converted to whole union. So that is done in the last one. Okay. So that one is 1 minus P of E union F. And here what happened? Union can be converted to whole intersection. Two De Morgan's law are there.
okay.
Is it clear? In set you have studied two De Morgan's law. Two subdivisions are there for De Morgan's law. One is union to intersection, other one intersection to union. Then this is 1 minus P of E intersection F. That is normal complementary rule. Is it clear?
Yes.
Okay, next. A and B are even such that P of A is equal to 0.2, P of B 0.48, 0.42, 0.48. P of A and B is 0.16, 0.16. Find number one, P of not A. Number two, P of not B. Third subdivision, P of A or B. P of A or B. Third subdivision, P of A or B. So this one you can try doing as homework. So I will give you DPP also based on today's topic, okay, and practice today's sums very well. And the next class, the remaining sums of probability we will discuss. Probability is a scoring chapter, okay. Everyone should practice it well, and you have to get full mark from this topic. Any doubts, children, based on today's lesson? Any doubt? Hope you all understood the sums very well. Okay, thank you all. Next class, it will be offline and online. Both will be there. Okay. Yes, thank you.
Thank you, sir.